I'm sitting at my desk with the lights off, and right now, this illuminance meter is showing that my desk is lit with about 1,000 lux, which is pretty comfortable for working. But what if I wanted to predict how much light was going to be in this room before I built it? Well, I would use a computer model of this room, and from the sensor point, I would project rays out into space. And the amount of light that hits the sensor point is the integral of the rays coming in from each direction to that sensor, including those that go out through the window. That means that once I calculate those ray values, I can combine them all to get the illuminance value at the sensor. And that would tell me the illuminance at this point in time based on the sky that's out there right now. But in an hour or 2 hours, the sky is going to be different from what it is now. And in about 4 hours, there'll be no light coming through the window at all. So how can I make these predictions for an entire year instead of just one point in time? The way that I do it is by dividing the sky into a number of small pieces. And there's some debate about how many pieces are necessary, but typically we use about 145 pieces. And I can treat each of those pieces as a separate light that's lighting up this room. And I can adjust the brightness of each of those pieces to match the sky at any given time. So what I'll do now is to send out rays from the sensor again, and this time I'll record which light or which portion of the sky each ray hits. And then that value, that amount from each portion of the sky, is called a daylight coefficient. And I can multiply the daylight coefficients by the brightness of each patch at any given time to calculate the brightness of this sensor at any time with just a set of multiply operations instead of doing a full ray tracing operation. And that turns out to be much faster and allows me to do annual calculations of lighting in this room.